Taulua is the 32-foot catamaran that we built to scale from this model. We evolved the model over a period of a year until we were satisfied with its performance. Taulua is built with split ashwood and recycled pine, covered with a skin of paper, canvas and tar. The design of the hulls and sail of this boat are unique, combining modern technology with boat-building crafts from across the ages to produce a boat that could not have been built at any other time. We built her in the Cotswold Hills in the west of England, and we launched her in the River Severn in 1982. That same year, we sailed her to the Canary Islands, and from there across the Atlantic to Barbados, and later through the Panama Canal and up the west coast of Central America to Mexico. Every morning, we unveiled the hulls. We built the hulls to this point during the very first summer, which was mostly dry. Here you see the first stage of building. The ribs are made of steam-bent ashwood and the stringers of pine. Our runer is tree nailing the pine stringers to the ash ribs. Notice the round curve at the stern and how the ribs are U-shaped amidships, and as we come more towards the bow, it is V-shaped. Our runer is applying wood treat 55. This is to preserve the wood. This remarkable paste soaks into the wood over a period of about 2 weeks, giving the best possible protection. Here am I, bringing the supplies for the winter. You can see from the fog, it's November. We're going to need to build a shelter for our boat. During the summer we have been living in a tree house overlooking the site. Our runner carries boxes of dates and all sorts of dried produce to keep us going over the winter. This is the giant turtle. It is made from fruit-picking ladder poles, joined together and curved into giant bows and covered with big sheets of transparent plastic to keep off the rain and the wind. We stapled the plastic down, and then over the end sections of the turtle we fastened a green plastic tarpaulin that could be rolled back in hot weather or tied down to give full protection in wet weather. Soon after finishing the giant turtle, we had our first storm, and everything was put to the test. The giant turtle resisted the gale force winds beautifully, but we found that every morning inside the turtle, the condensation was tremendous. So we had to add an extra inner layer of plastic higher up, and then we were fine. This is Seville, our mascot. He appeared out of nowhere, and because he is so beautiful and curious, we adopted him. Here he is exploring the hull and seeing just how narrow are the gaps he can squeeze through. This is the boiled down tar that we plan to use. Note that when hit with a hammer, it shatters like glass, yet if left alone, it runs like treacle. So we decided to modify it by adding a little asbestos powder. This completely changed its nature. Now it was plastic when hit with a hammer. It was more like lead, very malleable. Without the asbestos, the layers of canvas tore apart easily, but with the asbestos, the sheets of canvas stuck together very firmly. Next, we made a sample of the hull wall with canvas and layers of paper, just as we planned to build the final hull. I loaded it up with about 50 pounds of stone, and with a tractor we dragged it along the gravelly highway. It was undamaged. The tar acted like a lubricant sliding over the gravel. The most severe test was slowly driving the tractor over the sample on top of a pile of broken rocks, and to our amazement and great relief, we found it was unharmed. Here is the tar. It's a byproduct of making charcoal. We had to boil the thin, raw tar down because it also contained water and lighter distillates like creosote. We found boiling down the tar was very dangerous because it could bubble over like boiling milk and very easily catch fire. The drum had a very tight-fitting lid. We wrapped the drum with insulation to make it easier to control the temperature. We fitted a thermometer so that we could easily control the temperature. This very long tube proved to be a very efficient condenser. We collected creosote in containers. Meanwhile, Aruna was preparing the first canvas skin for the hulls. She was cutting up and sewing up the tarpaulins that we had brought with us from London. Once in place, we poured hot tar onto the canvas and spread it with a spatula. We used a catalytic gas heater to heat the tar very hot, to drive off any moisture and make sure the tar penetrated as much as possible through the canvas. Then we flipped the canvas over the top of the hull. And stretched it tight with a special stretching device I had made. We stapled it down with stainless steel staples, a slow process but very necessary. Finally, Aruna went around nailing it down firmly with wide-headed, hot-dipped galvanized nails. Then we had our first snowstorm. By this time we had moved our treehouse down to make the Turtle's Head camp, and we had cut piles of elm wood for firewood. We lit 2 fires in the giant turtle to keep the chill out. This is the sign of Chamberlain's paperwork factory in Nailsworth. Here we found Alan Beale, the manager, who showed us how to tell the quality of paper by the length of its fibre, called the grandfathers. He found us the best quality craft paper that had only been recycled once, and we brought a trailer load of this paper up to our camp. Aruna cut up the sacks to produce large sheets of paper. We dried this paper over the furnace so that it was hot and completely free of moisture. Then I pasted it onto the canvas skin of Taulua. It was a bit like papering the wall of a house. We kept the tar hot by keeping it in a pot insulated with corrugated cardboard, and we found that these curious tar brushes were available in the local hardware stores. We built up hundreds of layers of tarred paper like this. For the final layer, we had an excellent canvas we had brought from a mill in Ireland. Aruna cut it out to her pattern and sewed it up with this last skin of canvas on this treadle sewing machine. Now we stretched it out, and we nailed it with the same hot-dipped galvanized nails. Finally, we heated up the whole skin with a catalytic heater, and we rolled it very hard, squeeze out any trapped air bubbles that may have been left inside between the skins of canvas and paper, and to ensure the complete penetration of tar through all the paper and canvas. Next were the elm wood keels, or rubbing strakes. Elm is a wood that is very resistant to water. This is the biggest elm tree, and we felled and laboriously cut it in half with a chainsaw. Elm is very cross-grained, and so we could not split it. Rubbing strakes are fitted so that when the boat goes aground, it rests on these rubbing strakes and doesn't damage the skin. Now I am making the bolts to fasten the cross beams to the hull. At that time bolts were very expensive, so I welded them from studding an iron bar. The beams are fastened in place between double gunnels in double shear. I am making a hole in the center of the beam in the neutral axis so as not to weaken the beam. We had made this travelling furniture when we were living in London. We made the boat to fit these travelling chests, so we didn't have to make any interior furniture for our boat. We cut out the deck beams from the best pine wood we had brought from the old station camp in London. The decks are slightly curved to shed water. This is the template for the curvature of the decks. I roughened the surface of the deck so that the glue would attach well, and for the same reason I roughened the surface of the sheets of waterproof ply. We like this brand because each sheet was stamped with the sign of the seal, which we considered to be a good omen. This is one part of the urea formaldehyde glue that we were spreading on the stringers, and the other part on a sheet of plywood. We had to fasten them down very quickly before the glue had time to dry. Now for a spade with very fast hammering, with these 2-inch hot dip galvanized nails. Our next move was to cut out the mast step and mounts for the lee boards. For this, of course, we used elm wood, because it is so cross-grained and is very difficult to split. And this is just the quality that we needed for the mast step and the lee board mounts. This is our marvelous Dan-arm chainsaw made in the factory below. The rough piece of wood that we cut with the chainsaw, we refined to a flat mast step. Once we had the base flat, then we could draw the shape of the whole mast step. This is a fast way to cut a piece of wood to shape. Our unit paints hot wax over the end grain of the wood. Since the wood is green and will dry during the period while we finish the boat, we need to prevent